Hi, Victoria. We'll go through these together. Okay, so the problem tells us that we have men's heights with an average of 68.7, standard deviation of 2.8, whereas women's heights have a mean of 64, standard deviation of 2.5. We're dealing with a doorway that's 80 inches. And what we want to know is what percentage of men are too tall to fit through, what percentage of women are too tall to fit through. So we're going to go over here and look at our calculation for the z value. It's x, some value in our population, minus the mean divided by the standard deviation. And now let's look at what we're looking at. Okay, if this is the mean height here, okay, right, and 68.7 or 64, depending on which one you're looking at, we're looking for a value way over here, 80 inches. Okay, the problem gave me that it was an 80-inch doorway. So what I'm looking for is this area here that's 80 or above, right? That would represent my population that's too tall. And now that's going to be important in a minute. Remember, we call this a right tail test. Okay, because we're looking for the heights that are greater than or equal to 80 this way. Okay. All right, the first thing we're going to do is calculate our z for each of these. Dealing with men, I have an 80-inch doorway, so I'm going to put that in for x. Subtract off the mean, divide by the standard deviation. Plugging that into my calculator, I get a z equal to 4.04. Okay, and now I'm going to do the same thing with women. So this is two different problems. Z is going to equal 80 again because the doorway height has not changed. But now my mean has, it's 64 divided by 2.5. And in this case, I get a Z of 6.4. Now these are my Z values. These are not percentages of probability. So I've got to go to my Z table to figure out what is the corresponding value. Now remember, when I go to my Z table, okay, in the book, table A2 in the back of your book, the Z table always gives you the left area. In other words, looking back up here at my graph, if I look up those values in my Z table, they aren't going to give me the area to the right. They always give me the area to the left. So the Z table is going to give me the area in here. But I'm looking for the area on this side. Remember that the entire area under the curve is equal to 1. So in order to get the area to the right, I'm going to take 1 minus the left area, and that will give me the right area. Okay? So what I'm going to do is look up these values in the table, 4.04. So I need to go to the positive side, right here, positive. Down here I look up 4.4. This tells me my first number and my first decimal place, and across the top I found my second decimal place. For example, this is 4.04, so I would look down this column. Okay. However, what happens in this case is that my number is actually off the table. 4.04 is greater than 3.50. So I'm going to actually use this value 0.9999. Okay. So according to the table, when I look it up, all right, I'm going to get 0.9999. Okay. And now, like I said before, my value is going to be 1 minus 0.9999, which is going to give me 0.0001. Okay, but now it asks me for a percentage. So whenever I have a number and I want to convert it to a percentage, I must multiply that by 100. So I get 0.01%. Okay, and now notice over here that this value is even larger. All right, if this is already at 0.0001, the probability here is going to essentially be 0. It's going to be even smaller than that. So multiply that by 100, and I would get 0.00%. Essentially, it's 0% of women will be too tall to fit through the doorway. So that is the first part. The last part of that problem asked me to determine if a statistician designs a house so that all doorways have heights that are sufficient for all men except the tallest 5%, what doorway height would be used. Okay, so now I want to figure out this value. All right, I want to figure out this value. It's no longer going to be 80. I'm going to deal in the min because that's what it says. I'm going to deal with this and this. All right, and now I need to figure out my z value. Okay, so I'm going to use the same formula. Z is going to equal, I don't know what x is, but I'm going to subtract 68.7 and divide by 2.8. Okay, now x is what I'm looking for. What do I know about z? Well, it tells me in the problem that I want to include 0.05. Okay, it said 5%. That would convert to 0.05. Now, instead of looking up 0.05 in my table, now I'm going to look up 0.05 in the body of my table. But again, okay, let's look at this graphically. I have my mean here. I'm looking for the value that gives me this on this side to be equal to 0.05. Again, my table is a left tail table, not a right. So I need to find the area this way. Okay, that is actually going to be 0.95. Why is that 0.95? Because the total area under here has to equal 1. If the area to the right is 0.05, that tells me that the area to the left must be 0.95. So I am going to actually look up 0.95 in my table. And it's so important here that there's actually a star. Notice this is 0.9505. This is 0.9495. All right, and if I come down here, it tells me the value is 1.645. Okay, so I'm going to fill that number in for z. 645 is going to equal x minus 68.7 divided by 2.8. And now from here, I can just solve for x. I'm going to multiply both sides by 2.8. Okay. So I get 2.8 times 1.645 is 4.606 equal to x minus 68.7. And last, I'm going to add 68.7 each side. Okay, and I get a value of 73.3 equals x. In other words, if they make a doorway 73.3 inches, it will guarantee that 5% of the population will have to bend down, or 95% of the population will fit through with no problem. I hope this helps. Let me know if you need more help.